Hello everyone. I'm going to talk you through the pre-lab for titrations and determination of an unknown acid's concentration. Checklist of things to do. So, as per the last experiment, you've got to go multiple places, right? So one, okay, go to the Chem 101 group site at Canvas. Get yourself an unknown sheet, okay? So this, okay? Eventually this is what you're gonna complete and send to me as an email attachment later, okay? Okay, so you'll email me that on the I'll make the deadline Friday, all right? So I'll make the deadline for that Friday. Email me this sheet completed with your name, of course, the date, sample number. I'm gonna send you an email. Okay, let's write that on the checklist. I'll email you your assignment number 1 through 12. Mark it here, okay? So everyone has a different unknown. We'll have a different answer. Make sure you fill this out for credit. A big fraction of the grade is going to be how close you are to the correct answer, okay? And then, show calculations below. The best way to do this is probably just, write it freehand if you can, okay? You can type if you want, but freehand's better because it's hard to show work of the type required using just a word processor. Okay, so download the data sheet, check Canvas for your assignment email, okay, and then go to Pivot to complete experiment. Okay, so you go to Pivot, complete the experiment. You have to type in the unknown at Pivot, right? And then, submit answer sheet. So this essentially turns into this after you watched the video, okay? So just to recap there, go to Canvas, go to the Chem 101 group site, download your blank data sheet, check your email, which I'll right after this video. It's Tuesday morning right now, so probably late Tuesday morning, early Tuesday afternoon, check your email for your assignment ID, which will just be a number between 1 and 12. Type that number in when you go to the Pivot site, and you'll get a unique titration. Complete the assignment there, and then remember, there are things you fill in there which get submitted, but a big fraction of the grade is here. This final value here is going to be worth some points, okay? Some big fraction of points, maybe 40%, right? So make sure you complete this and show sample calculations. All right, so let's get into the experiment, okay? We're going to be doing acid-base titrations. Now, if you like, titrations are simply slides and ladders in a lab, right? Okay, so you're able to add, it's kind of a neat piece of equipment, and I'll probably put a video up or a link to the video of someone actually using a burette. You use one in the video for the Pivot. I'll show a demo video, so look for the link somewhere. Okay, and you'll see how a burette is used to actually get the balanced equation, so to speak, is actually kind of satisfied in real life. So you add exactly the right ratio of typically base to acid, as you would in this experiment. And right when they're stoichiometrically equivalent, so it's 1 to 1, whatever the stoichiometric balancing numbers are, when it's exactly 1 mole and 1 mole being combined, or whatever the number of moles is, just has to be equal, okay, the solution will change color. So there are indicators out there, we'll get into it, that change color when solutions become neutral, okay? So indicators of chemicals are the one color in acid, one color in base. When they switch, you see a color change, right? Okay, and that's when they're exactly equal. Maybe you've done a titration in high school, okay? So all acid bases are neutralization reactions. So it's acid plus base turns into salt plus water. Okay. Now I'll do the classic generic, right? Your experiment, you'll actually look at HCl and NaOH in the second part, but in the first part we use a different acid, okay? So in the second part you'll have HCl, which you've got to find the concentration of, right? You'll add NaOH from your burette, and that'll turn into NaCl plus H2O. Okay, all right. And when you've added exactly equal amounts in a 1-to-1 ratio, you make these products. If you have any acid left over, it's one color. If you have any base left over, it's another. And so when we see the change, okay, so it goes from colorless to pink when I have an excess of OH, right? We'll see that in the video. I stop right when it changes color, okay? So when you do a titration, you always stop right when you get a color change. That means this is perfectly in ratio at that point, okay? Now, we haven't talked about concentrations yet. I'll talk about it a little bit here, okay? And it'll set you up nicely for the next packet. But simply, you can work out the moles, because 1 mole balances 1 mole. You can work out the moles in a solution by its strength times its volume, which is actually pretty straightforward. We'll get to it formally in class, but you know, we'll see it when we get there. All right, so at equivalence, when you add exactly the same number of acid to the same number of base moles, right? That's called the equivalence point. Moles H plus is identical to the moles of OH minus. Okay. And essentially that's all a titration is. You're making the moles of the two reactants the same if it's a 1-to-1 ratio. And when that happens, you see a visual indicator and you can actually do some math. So we'll get into the math as we go. All right. Now, you actually have a 2-part experiment and you've got to be kind of careful, right? Okay. Part 1. Standardization of NaOH. Okay, so you actually have 2 titrations. Okay, you've got to find the concentration of sodium hydroxide, which will then take forward to part 2 and do a second titration to find the concentration of HCl. Okay, now in your lab we'd make a big fuss about making this solution up, okay, which I don't have to show you because you kind of do it on the video. But the bottom line is this, okay, so acid plus base makes salt plus water. So the acid is actually KHP. Now that is not its true formula. It's P is not phosphorus. Not phosphorus, it's phthalate. Okay, potassium hydrogen phthalate, that's an organic anion there. We just write P for abbreviation, okay? And that has a molecular weight of 204 grams per mole. And that thing is a solid actually, right? So this is called a primary standard. If you have a pure material that's a solid, it's crystalline, there's nothing else in there with it. So if you weigh out, you know, it's 204 grams per mole, right? So if you weighed out 204 grams of KHP, you'd have exactly 1 mole of KHP, all right? So figuring out the moles for a pure solid is much easier. That's why we kind of take it off and use it as a standard, right? And what you're going to do, you're going to react it with, that's the acidic proton if you like, you're going to react it with NaOH, you're going to make a solution there, okay? And then you'll turn it into, and this solution will be used in part 2, okay? It turns into acid plus base, salt, so NaKP if you like, plus H2O. That's aqueous. Okay, so they're in a 1-to-1 ratio. Okay, now rather than draw a bad picture, I'll actually find a picture on the internet and show you what a titration looks like. Okay, but very simply, just hopefully, maybe I'll make mine on the right here and hopefully squeeze the other one in over here, right? So when you do a titration, you always have the acid down here, right? So what you're going to do, let me just, you weigh out some KHP powder, all right? So you weigh out the KHP powder and you weigh by difference into a flask, right? And then you dissolve it, that's what I did there, then you dissolve it to make a solution. So that's KHP aqueous, right? In other words, there's H plus ions in there, right? You have, because there's 1 H plus per molecule, right? You know the number of H plus ions in there, right? And then you do your titration. Okay, so you have up here NaOH. Okay, so that's that guy. So you have a little, you've seen this on the video, you turn the handle, the sodium hydroxide drips in, you swirl it around, and then when it just turns pink, moles of acid equals moles of base, right? So at equivalence, moles KHP equals moles NaOH. Okay, so that's the key fact, right? moles KHP equals moles of NaOH when it just turns pink. Okay, so you'll titrate on the video until it just turns pink, and you'll record the initial volume. You know, if you're smart, you set that up to 0. Maybe it goes down to 25.5 or something. 25.5 milliliters is the volume added, right? Now that's important because this is a solution. We'll talk about solutions in a second, okay? So if I do my triangle, molecular weight, grams and moles, right? For a solid, moles is grams divided by molecular weight. So moles, so grams KHP divided by molecular weight KHP equals moles of NaOH. Now here's the thing, you may have seen this before. Moles, I do another triangle, concentration, moles per liter. Basically, think about it. If you think about it, if I have a volume times a concentration is just strength. How many moles are in 1 liter? So if I have a 1 mole per liter strength solution, 1 mole is swimming around in 1 liter volume, right? So moles per liter times liters is then moles, right? So if you think about moles per liter times liter equals moles. So moles equals CV for a solution. But got to be careful, the volume has to be in liters. So if you look on your chart here, be careful, it says milliliters. Turn to liters for math, right? So be careful, all right? So if you like, you could put divide by 1,000 there if you like, because then, you know, you turn milliliters, 2 liters on the fly, so to speak, all right? Now, remember, the goal of this experiment is to find this, right? So just rearrange it. Concentration NaOH equals grams KHP, molecular weight KHP, which is 204.2 or something grams per mole, divided by volume NaOH in liters. All right. So that's the point of part 1, okay? So if you do several titrations, work out, maybe you do 3, work out 3 concentrations, maybe it's 0.105, 0.103, 0.107 or something, and then make an average, find the average concentration of NaOH. All right, so hopefully that makes sense. All right, I will put a link to, again, as I mentioned, I will put a link to a video with titration so you can actually see this in practice. I advise you to watch it. But very simply, just to recap, acid plus base makes salt, acid plus base makes salt plus water. When these are in equal amounts, we see a color change. So we combine them until the color change happens. At that point, moles acid equals moles base. For a solid, moles is grams divided by molecular weight. You weigh your KHP powder, you dissolve it in some water. It doesn't matter how much water you dissolve it in if you think about it, because it's not changing the weight of KHP, it's just swimming around, right? Grams divided by molecular weight is moles, KHP. That equals what we want, the concentration of the sodium hydroxide times its volume in liters. That comes from the burette. So if you go from 0 to 25, you added 25 milliliters. If you went from 1 to 26, you also added 25 milliliters, okay? So it's final minus initial burette reading. That's why we like to go from 0, because you subtract 0, it's the same number. Rearrange it, find the concentration. Fabulous, right? So we found the concentration of NaOH in part 1. In part 2, it's that same titration we looked at on the first page, okay? So we're going to have this now as our unknown, and this we've just found its concentration, right? So it's the same titration, the classic titration, but we're going to do it now for points, right? So HCl plus NaOH turns into NaCl plus H2O. I write it as I like to write it, like that, right? Okay, so we know the concentration of this guy, right? Okay, we're going to set it up again. So I'll do another bad drawing. All right. So should you do this in lab, just keep that same NaOH in the burette. But down here, we've got our test HCl solution. Now, I can't remember how many milliliters you use for that, but it's okay to go. It's good to go. Now, here's the thing. So at equivalence, one of these reacts with one of these. When they're exactly the same amount, it changes color. So moles HCl is moles NaOH at equivalence, all right? So moles equals CV for a solution. Both of these are solutions. They're both aqueous, right? So moles equals CV. So concentration HCl times volume HCl equals concentration NaOH, volume NaOH. Now here's the fun fact, right? You could turn the volumes into liters and it would still work, but because you're going to divide milliliters by milliliters in a minute, it will cancel the units. So for this one, you don't have to change. You can keep everything in milliliters if you want. You can keep it in liters if you want, but keep a consistent unit, one or the other, right? Our goal, of course, is concentration of HCl, CNaOH, that's from part 1. VNaOH, that's the burette, that's this thing, right? Divided by VHCl, whatever you put in the flask down here. I can't remember the number from the pivot, maybe it was 50 milliliters or something, I can't remember, right? But whatever that number was from pivot, right? And you work it out, and hopefully you're going to get, I can't remember the actual answers, but it's typically things in the 0.1 range, okay? So maybe your answer will be 0.1 through 0.3 maybe, with 3 significant figures, most likely moles per liter for the answer, okay? Make sure that goes on the data sheet. So, you know, summarize your answers here, show the calculations just like I've done. I think it says on pivot, don't do this. Huh? That's how you work it out. Do that, right? So CV equals CV for 2 aqueous solutions during a titration, okay? If we had something that was dibasic, which was like, you know, the balancing numbers weren't 1-to-1, then we do a slides and ladders, okay? Because when you have non-1-to-1 equivalents, the math gets a bit more complicated. We'll talk about that in a couple of packets time, but for now, hey, it's all 1-to-1. The first one with KHP, 1-to-1, right? This one, 1-to-1. So 1 mole equals 1 mole, CV equals CV, we're good. Okay, so this is okay. Okay, this is okay to use. All right. Okay, so I think that wraps it up. Again, let's just summarize what you got to do. Go to the Chem 101 group site. Go to the Chem 101 group site. Get your unknown data sheet printed off. Okay. Check your email. Today's Tuesday. Sometime on Tuesday, you'll get an email assignment with your assigned unknown 1 through 12. Then go to pivot. Once on pivot, begin the experiment and enter in that 1 through 12 number I assigned you, and you'll get a different unknown than everyone else. When you've got your math and when you've got your experiment done on pivot, as you go, remember to kind of fill this out as you go, right, on pivot. When you've got that complete, submit that answer sheet to me. Make sure you show those calculations, okay? So those calculations, we did it in the Prelab. Show me how you got the concentration of NaOH, include any averaging. So that's the calculation of the concentration of the standard, right? And then for the marbles, right, for the points, how good can you get the concentration of HCl? There we go. All right. Okay, hopefully that makes sense. I'll get this posted right away, and I'll make this due. I'll write it here. What did I say? Make it due on Friday, right? Because you guys have an exam this week, right? So I don't want to stress you out with having a deadline on this this lab, right? So the exam will be given out on Thursday, and you'll have, you know, literally all Friday to do it. I advise you, even though I'm putting the deadline at Friday to this, I advise you to get it done by Thursday before the exam arrives, okay? So you have Tuesday, Wednesday, Thursday to get this done, but I'll stretch it out if you need the time, okay? Stop there. See you guys next time.